Okay, I think we can slowly start. I will start presenting our webinar. So we are here today to watch Simplify Multi-Cloud Traffic Management with KubeLB from Kubernetes, and we have Khalid Malik with us, who's gonna show us around KubeLB and what we are doing. For some organizational details that you might be interested about, we are recording this session, and we will share the recording with you so you can share it with your colleagues. We will also add the recording to a website, to a YouTube channel. We will send it to you so you can check everything out. But it will now present everything, but there will also be a Q&A afterwards, so you can ask any question you might have. You can use the Q&A section here in Zoom to do so. You can just write your question, Walid will see it, and then he can reply to it. And I think that's more or less everything organizational that you need to go to know. It's going to be for a whole hour. He will be speaking around 45 minutes, and then we will have some time for the questions and answers. And yeah, thanks a lot for joining. Welcome. And Walid, if you want to start, the stage is yours.
Yep. Thank you so much, Mara, for the introduction. So welcome, everyone. It's nice to have you all here. So the webinar is mostly focused on KubeLB. It will be a hands-on webinar for KubeLB, but mostly around the issues or problems that we faced within the Kubernetes realm or within the load balancing application delivery realm, in particular, and how we went ahead with KubeLB and how it solves those issues. So just as an introduction, my name is Walid. I've been working at Kubernetes for the past 3 years and working in the field of Kubernetes, so in different roles, basically, in and around Kubernetes for the past 6+ years. And moving forward, so the agenda is kind of clear. We will start with the problem statement, like why we think the traditional load balancing and how load balancing is implemented right now in the cloud native world, and particularly in Kubernetes, is not sufficient, is not scalable. And then that would help us introduce KubeLB, like why we think it can solve the issues and why it could democratize the load balancing parts of Kubernetes. Afterwards, since it will be more of a hands-on demonstration, we would deep dive into the two of the main features, so the layer 4 load balancing and layer 7 load balancing with live demos. Eventually, a bit light on the future goals of what you can see us doing, or which areas you would see us target for KubeLB in the future. And we would like to delegate 15 minutes for the Q&A, but feel free to ask your questions whenever you want. You can write them down as soon as you find some feedback or something interesting, and eventually there will be a dedicated session to answer all of your questions. So let's get started. So I know it would be boring for a few people who are already within Kubernetes, but I think history is a bit important. So just going with the history of application delivery and deployment in particular, I think everything has been revolutionized in the past 20 years. More or less, it started with monolithic applications where a single application would have all of your code base. And then those monolithic applications were being deployed within your VM. So there were even dedicated servers where your applications would be hosted. And this required a lot of babysitting, so they were treated as pets and not kettles, because you have to manage your VMs, you have to ensure everything within your VM is working fine, and it was not scalable. And then it was introduced earlier on, but Docker basically, I think it didn't introduce it, it commercialized it. And that's when the adoption really it skyrocketed, was when containers were introduced by Docker. So the shift started from VMs with dedicated OSs and dedicated servers to basically shifting all your workloads to containers. And containers were scalable till a certain point. I think using Docker Compose and Docker, I think it already gives you quite an edge in maintaining your workloads. But then again, large IT companies, if you have a bigger footprint, you would have more applications or more workloads that you need to manage. And eventually, Docker or containers, they can't scale up to that mark. It's difficult to manage them. And then came in, I think, 7 years ago, 9 years ago, actually. Then Kubernetes came in. It's a beast in itself because it's a huge project, and some people find it quite complex. But the main thing that it does, and it does brilliantly, is managing your workloads. So the orchestration for your containers and containerized workloads, it does it quite brilliantly. And you can have a single platform or a single cluster, let's say, in which you can scale your workloads, your scaling of your workloads, resilience, management, basically even automation of operations. So for example, how you can manage multiple applications, everything was more or less standardized by Kubernetes. Of course, I'm well aware that there are competitors for Kubernetes as well, which simplified similar to how Kubernetes does it. But within this webinar, we will be more focused on Kubernetes and the cloud native realm in general. So yes, like I said, there was a huge transition within the past 2 decades, based on application deployment. So how your applications are deployed, and eventually, of course, how those applications are delivered as well. The application deployment part, I think, has seen drastic changes and good ones, but the application delivery part, it still lacks a bit when it comes to load balancing, traffic management. Those parts are still, Kubernetes is not, I think, up to the mark for that. And yes, so going through the shift again, like I mentioned before, monolithic architecture was firstly adopted. It does not support multi-tenancy or multi-cluster or multi-deployments for applications. It would assume that you have deployed your application either in one place or have some sort of you're managing your own infrastructure in a way that it could load balance into multiple applications. And due to the adoption of cloud native architecture and the whole movement basically shifting from managing your own VMs to basically moving more towards a cloud native approach, it helped us improve. It improved a lot of factors. For example, the scaling of applications, how the services are deployed, like how you interact with those services. Because if you use something like Kubernetes, it allows you to communicate with everything using a standardized API, which is the Kubernetes API. So a lot of it changed. But as I said, it brings in a lot of, I think, the application deployment part, it got better and better. And I think it's at a very good stage right now. But the application delivery part and the load balancing in general, it still lacks a bit. Because Kubernetes, although it is designed for workload orchestration, but it does not present us with any inherent or, let's say, inbuilt load balancing solution. It's mostly dependent on either third-party applications or something external, like your cloud solutions, to basically provision load balancers for you. And these are basically all the issues that we see when during the application delivery process. And application delivery, of course, it covers topics like traffic management, load balancing, security controls, and data management for you. And all of those parts, basically, we believe could be improved. For example, right now, within the Kubernetes realm, if you have a single cluster, yes, you can still deploy something, for example, like MetalLB, and gain load balancing functionality. Or if you have the cluster already using the cluster is already using a cloud controller manager. Let's say it's already built on some cloud, like you're using a managed solution like AKS or EKS. It already gives you load balancing out of the box. But when it comes to bare metal and on-premise installations, this functionality is not there. So you either are reliant on a third-party vendor, which again gets you into a vendor lock, and you have to pay hefty prices for those load balancing solutions. But either you have to rely on something third party, so outside of Kubernetes, or you have to run your own solutions on each and every cluster. And in both cases, these things are just not scalable. It's just not possible to scale it because the scaling becomes inefficient because each cluster will now have to have its own configuration. So when it comes to, let's say, IP management, right? Each cluster needs to know which IP range it can access for load balancing, and it can and all the validation. So basically, this cluster should not go into another IP range. So let's say go into a CIDR range that it's not allowed to. All of those validations and this configuration, like which IP range can this cluster use, it needs to be done per cluster basis. And this is, it requires a lot of operational overhead. You need a lot of management costs to basically manage all those clusters as pets instead of them as a fleet of clusters. And other than that, of course, when you're talking about exposing your applications or delivery of your applications, security and DNS becomes a core objective. And in this case, there would be no, again, Kubernetes does not offer any centralized DNS certificate or even security automation or things like web application firewalls. They're not inherently available. But of course, there are multiple solutions available which you can use to implement them or use those features, but they're already available for a single cluster. There are not much of solutions available that could help you in a multi-cluster environment. So all of these considerations were all of these challenges were hindrances that we were facing at Kubernetes as well on a daily basis, because a lot of our customers, they rely on bare metal on-premise installations of Kubernetes, and then managing their IP address range, managing their load balancing solutions per cluster was becoming quite hectic, even for us. So we thought, why not build something on the same principles of cloud native solutions and Kubernetes-native solutions and build something that can scale. So that basically resulted in the product that you are seeing right now. That's KubeLB. So we don't see KubeLB just as a layer 4, or let's say a load balancing solution. We see it as a complete suite of products, or let's say a product in itself that will be an application delivery platform. And again, for an application delivery platform, it needs to handle your traffic, so traffic management, load balancing, your security controls, and the data management as well. It's a suite of products shipped so that they can all manage it from a central point. So instead of managing everything like you see in the diagram below, diagram on the left, so instead of managing everything per cluster, we built something that can manage your clusters and your load balancing requests in a centralized way. So features like load balancing, again, traffic management, automation for DNS and TLS, and security controls, and much more, of course. It will be covered going forward. And this is what KubeLB is basically built for. So the key benefits, of course, like I said, gist of like the essence when we wanted to create KubeLB was that we want to be cloud native and we want it to be Kubernetes native as well. And what it gives us is basically a centralized solution that can manage your clusters, whichever the environment or cloud or wherever you have them hosted. You just need to give it a fleet of clusters that need load balancing services from KubeLB, and it would provision it for you. And then it can, of course, since it hosts a data plane, it can manage all the traffic. So things like traffic shaping, securing your traffic, everything can be done from a centralized point. And what it also does for your organization, of course, is that now instead of managing multiple clusters and individually managing your load balancing configurations within each and every cluster, you can reduce the cost and the effort required for your application delivery by simply delegating most of this to your centralized control plane, that is KubeLB in this case. So your application developers, or even your cluster operators, the ones that are individually managing those clusters and the applications deployed in it, they can focus on application delivery, application development, and all the other aspects. So basically, how should the load balancing work, the assignment of load balancing IP, even the propagation of things like DNS and certificates, it will be delegated to KubeLB. It will be delegated to a central unit that can manage all your fleet of clusters. And of course, with its validations, with adding certain limits, so how many load balancers you can provision and all of those parts. So limiting the resources as well. There's a lot less babysitting that you need to do, or let's say a lot of less management that you need to do when you're using KubeLB. So again, it's mentioned as a core value proposition, and we specifically didn't call them features because we believe that these are the foundational values that KubeLB introduces, and it introduces and the being cloud native and specifically being Kubernetes native helps us achieve all these features. So things like multi-tenancy, scalability, security, integration with Kubernetes API, and of course, just like Kubernetes, you can deploy any observability tools to visualize all the metrics and everything from within your cluster. So all of this is pre-baked, but let's say it is there from ground up within KubeLB because we think these things should be available from day zero within our product. Because Kubernetes as a platform, it already offers you much extensibility that you can easily implement all of this. So these are the things that we believe will always be present in KubeLB. And now moving over towards the architecture. So KubeLB follows in general the hub and spoke model. It comprises of two main components. So like I said, there is a management cluster that is your centralized cluster where all your load balancing requests will be processed from. So as an example, this is where you run your load balancing appliance. So if you want to use something like MetalLB or maybe some external third-party load balancing solution, this is the only one point where you need to deploy that appliance. And then everyone else, so all the clusters or all the tenants where some load balancing is required, they would talk to this management cluster. Its communication happens one way. So the management cluster in itself cannot access the tenant clusters. It can access their node ports, but only for traffic flow. It does not know what's there in the tenant cluster, what's created. None of your private configurations, of course, with security considerations, are accessible from the management cluster other than your node ports. And the tenant cluster, it basically communicates and forwards all those load balancing requests to the management cluster. There was supposed to be a diagram around here, but I'm not sure why it's not visible somehow. Okay, so it's visible. it was divided into two sections. So again, like in this diagram, there is a centralized control plane, which is your management cluster. And then all the tenants, they basically communicate with your single control plane. And diving in deeper into the architecture now. So I think for simplicity's sake, we can skip it down into these 2 points. And we can ignore the second part. Basically, so the things that the 2 sections that you see below are tenants. These will be your consumers for KubeLB. So these are the clusters in simple terms that require some sort of load balancing. And they would communicate with your management cluster. And again, your management cluster, tenant cluster, all of these, the core requirement is that they need to be Kubernetes clusters. It does not matter how you bootstrap them, how they're created. The internal details are something that KubeLB in itself is not too much concerned about. I think the only thing that there are only two main requirements which were mentioned here is that the tenant should be able to speak to the API server of KubeLB cluster, so the management cluster, and the management cluster should be able to forward traffic to the node ports of the tenant cluster. As long as this requirement is met, your underlying configuration for management cluster or the tenant cluster, it does not matter. And for the flow of information, we can see that, so this is the management cluster, and this is the KubeLB agent. So how things work is basically all your tenants, they get a dedicated namespace in the management cluster. So the resources are not shared. They get a dedicated namespace, and even the communication, so the kube config to access, let's say, the management cluster in tenant for communication, it's scoped to your own namespace, to the tenant namespace. So you cannot see anything else from your cluster. All that is visible for you is basically just a limited subset of resources that you have requested. Or let's say that you have delegated KubeLB to manage. None of the native Kubernetes APIs, let's say, for example, secrets, config maps, deployments, they are accessible for the tenant. They can only access custom resources that KubeLB creates. And yeah, that's more or less it. So this is the first flow, basically. So the tenant basically creates, let's say, we scope it down to just services, and the tenant would create a service. Our agent is running on your tenants, and it would pick that service up and delegate it to the management cluster. So you would see basically a load balancer being created for your service request in the tenant namespace. And eventually, it would propagate all the traffic using Envoy as the data plane to your worker nodes. This high-level architecture, I think it's important to understand because most of our follow-ups would be divided into two sections. So we would divide it into layer 4 and layer 7 load balancing just for ease, and there would be two demos basically separately for both of those sections because we don't want to bombard you with all of the information right away. And yeah, so in this realm, like it's explained, the KubeLB in itself, the Envoy control plane, they are managed by KubeLB. So all of these resources that you see are being created in these slides, all of those are managed by KubeLB. You don't have to manage them. And KubeLB, of course, the agent would take care of all these translations. So if you create a service, a load balancer will be created. Let's say if you create an ingress, a route would be created in your management cluster. And then in your management cluster, the things that you need to manage are basically your load balancing appliances. So which tools would you need for actual load balancing? If you have, let's say your management cluster is in AWS, that inherently you can use the cloud solution that AWS provides, or you can use some sort of solution like MetalLB within that cluster, because of course, management cluster is a single cluster. So within that scope, the single cluster solutions, they work perfectly fine. And the multi-tenancy and let's say the ability to load balance between multi-clouds, that's offered because of how KubeLB is designed. And again, if you want layer 7 load balancing, you can deploy your own choice for basically ingress or gateway, whichever you choose. And yes, let's dive into layer 4 load balancing. I think the best way to demonstrate it would be a demo. But before we go into a demo, we can quickly go through the architecture. More or less, it's already explained, but the workflow for a user looks something like this. So a user would create a service. Of course, some pod or some deployment would be created, which basically is serving the traffic, because service in itself is just for internal Kubernetes load balancing. And as soon as the service is created, what happens is that it gets translated. it gets transported as a TCP load balancer via the KubeLB agent. So a service in your tenant cluster, it gets translated into a load balancer. And this happens automatically. And the reason why it is designed this way is because we wanted the user experience for the user to not change. We didn't want them to create some sort of new custom resource, or let's say interact with some sort of new API within the tenant cluster. We wanted the UX to feel exactly how it feels like when you are running, let's say, on an AWS cluster and you're using cloud load balancing. So this TCP load balancer is then created and KubeLB takes over from there. It would create all the required load balancing resources, and then it would propagate whatever the IPs are and whatever the status is back to your original service. So again, the propagation of status, it basically ensures that user wouldn't know like where this came from, or let's say how this service got updated. And this more or less explains the same thing. So basically, a developer as an entry point would create a service within your tenant cluster. That service gets routed via the KubeLB CCM to your KubeLB management cluster. And eventually some user basically, or your customer, would access this service that is exposed using KubeLB. So the ingress point, or let's say the entry point for your traffic, it would now be the KubeLB cluster. But KubeLB cluster would, again, be forwarding all your traffic eventually to your actual workload. And this is an example for a load balancer CRD. In most cases, I would say in 90% of the cases, you wouldn't need to create those load balancer CRDs by yourself. You would create a service and KubeLB would take over and then create everything else for you. But I think it's quite important to understand it eventually, because KubeLB is not bound just to this one topology, where some tenants are creating services and you get a load balancer in your KubeLB cluster. If you want, let's say, load balancing for certain VMs, or maybe workloads hosted in VMs or somewhere else outside of Kubernetes, you can still use this load balancer CRD and just provide your endpoints. And KubeLB would take over and take care of all the load balancing requirements. Okay, so time for the first demo, and then I would probably have to switch tabs. And for the demo, I think we wanted it to be more hands-on. So we would go directly through documentation. We would go through the installation of KubeLB. So both for the management cluster and the tenant cluster, one by one. And eventually, we would just deploy a layer 4 load balancer and see how it works. Let me prepare things. So I already prepared 2 clusters. First one is the CCM cluster, and second one is a management cluster. Both those clusters are already prepared. And for this demonstration, specifically for layer 4, we would simply use the community edition of KubeLB. KubeLB comes in 2 editions. So there's one community edition and an enterprise edition. Of course, enterprise edition gives you a lot more than the community one, but the community one that we have is completely open source and free to use for anyone that wants to. So I would just copy these 2 commands, and that's more or less it for installing the KubeLB management cluster, since it's just layer 4 load balancing. So TCP and UDP load balancing, we don't need any other appliance. And 2 of my clusters are basically on different cloud providers. So the first one, the CCM, it's hosted on Hetzner. And the other one is the management cluster itself is hosted on GCP. So that also gives you a flavor that multi-cloud or multi-environment, in this case with KubeLB, is not an issue. as long as tenants can interact with the API server of management cluster, and management can route traffic back to your tenants. Even hybrid solution, on-prem solution, everything should work out of the box. So now that our management cluster is set up and ready, we are going to install the CCM. And if you go through the prerequisites, it requires us to create a namespace. We will quickly do this. And another point is that for a tenant to interact with your management cluster, the first, let's say, handshake, it needs to happen at the management cluster. So you need to first register the tenant in your management cluster, and only then a certain tenant, or let's say a certain user, could communicate with your cluster. Otherwise, the communication doesn't happen. So we create a tenant in the management cluster. We can already see the tenant. It gets a dedicated namespace. So each tenant, like I mentioned before, each tenant would have its own namespace, and everything that a tenant needs, or all the requests, they are going to be managed within that single namespace. They cannot interact with anything else. And then following the same documentation, I don't need this because I already have some aliases set up for switching the kube config. But of course, like that is something that you can also do. And one thing that KubeLB does, and it automates, is that it generates a new kube config for each tenant. So your tenant shroud, I cannot show you the kube config, unfortunately, but the tenant that we created, it would have its own dedicated kube config. So anytime that you want to disconnect, let's say a certain tenant, all you need to do is just delete a service account. Let's say it's token that exists. And if that's deleted, their communication is completely broken. So it does not get, let's say, your admin kube config or some sort of global kube config by default. It gets a kube config that is scoped specifically to your tenant namespace. And this is just a simple alias. So instead of basically exporting kube configs, I already have aliases. So I'm just going to switch my cluster. And I'm going to quickly create the secret. So this fulfills the whole registration process. So I created my own tenant, tenant in the management cluster. I downloaded its kube config, and following the documentation, of course, I created the secret that is basically the key that is required for the tenant to communicate with your management cluster. And then afterwards, I can simply skip these parts and use the community edition. To install KubeLB. And yes, so as expected, all your tenants, they need to have a unique ID. So for example, when you see a tenant named Shroud, for example, they cannot be two tenants, and your CCM, or let's say your tenant, it also needs to be aware of that ID, because without that ID, it cannot communicate with KubeLB. So we would quickly do this one thing. Quickly give it the name. And install KubeLB. And we can already see that in both your CCM and your management cluster are now up. And that's how easy it is to basically just getting started with KubeLB. You don't need something, you don't need a lot of configurations. Eventually, these are just two Helm charts that you need to install. And then for demonstration purposes, since I think we're also a bit short on time, unfortunately. We can quickly go through this example. So, like I said, let's put a watch on shroud, and let's quickly apply this configuration here. And again, I think we don't need to go through the deployment and everything, but eventually it's just a simple service within Kubernetes that basically listens at port 3000. So nothing fancy, just a simple function. And just give me a second. So we can already see I created another service as well for demonstration purposes. We created two services, and what it gave us is, let's say if we have this service called backend in our CCM, you can already see that the IP has been allocated, and how you get the IP is basically, I'm in the wrong namespace. Just a second. Okay, let's see. And you get this IP using your management cluster. So your management cluster is basically responsible for the allocation of the IP, and it propagated that IP back to your user cluster or tenant cluster. So, like I said, this is where so your management cluster is where the IP allocation actually happens, and whatever the outcome is, it is simply propagated back to your tenant cluster as it is. And then I think we can also try it quickly, although the IP propagation, it does take some time. Yes. So now we can already see that our application was exposed, and this is my local workstation, so it's connected to the internet. It's not within any data center, so this IP has been exposed. It's accessible externally all over the internet as well. So yeah, what happens in, again, just for a quick rundown, what happens in your tenant cluster is you create a service of type load balancer. What gets created in your load balancer cluster is basically a load balancer for that service and an actual service, which basically is let's say shown here, which would actually create your, which will actually provision the load balancer. And then I think we can move forward. Yeah. So the next part, which is much more fancier than simple layer 4 load balancing, is layer 7, which is basically your application load balancing. And I would quickly go through these things because I think we're a bit short on time. But just to explain everything, the idea for layer 7 load balancing was similar to how we did layer 4. Initially, we did think about creating our own CRDs that you create in your tenant clusters, and let's say they are responsible for all the DNS delegation certificates and everything, but we always found that to be something that would add new learning curve and be difficult to maintain for our end users. That's why we went with native Kubernetes APIs. So your ingress resource or the gateway API, you can use it as it is. And KubeLB can take over and automate things like DNS certificates. It has other tools for security posture as well. All of that could be automated right away and managed from a single instance. So let's say if someone is running, I think more people are familiar with Nginx ingress, because I think that's something that's used within the industry pretty much. So instead of running Nginx ingress in 10 clusters, now you just need to run that Nginx ingress, let's say in one cluster. That is your management cluster. And then all your different tenants, they can forward all their ingress requests from their tenant clusters to basically the management cluster. And again, it follows the same philosophy. You don't interact with any custom resources, you interact with ingresses or gateway API. And from the management cluster, you can only see or interact with our own custom CRDs. So a user or a developer would create native resources. KubeLB would translate them into custom resources for you. And in terms of feature, again, we have community and enterprise edition. So the features have been split. Enterprise edition supports DNS automation, certificate management. You can also have your limits. So for example, provisioning a lot of load balancers could be very costly, and it could get costly. And as soon as you scale up, I think you need more load balancers, and then the cost just keeps getting up. So with KubeLB in a centralized way, you can limit load balancers per tenant or globally for your management installation. And then I think we just have a few minutes. So I already prepared for it. So what we are going to do instead of reinstallations, I already have an environment that I've configured for KubeLB. Let me have a management cluster and a CCM or a tenant cluster already configured. So let me quickly apply my resources and then zoom in a bit. So I think ingress should be much easier to understand because a lot of people already use it. So it's simple Hello World application that we are showing. And like you see, so you create an ingress, just like the normal ingresses that you would create. The only difference is that the class thing now needs to be KubeLB. This can also be shifted, by the way, to anything that you want to, but in general, by default, there's a class filter for all the resources, and the class filter equates to KubeLB. And then I have added two annotations. So the managed DNS annotation basically would automate the process of provisioning DNS, and certificate, again, would be used for certificate provisioning. So by default, instead of managing 50 things, so let's say having external DNS, tools like external DNS or Cert Manager installed within your cluster. And of course, if you install a DNS management tool, you also need access to the cloud solution, or let's say the actual hosted zone for DNS, which could have its own security considerations. So everything, again, would be delegated completely to KubeLB, and we can completely, and we can easily, just a second, so I'll apply it. So since we're a bit short of time, I could quickly go through it. So again, just like just like L4 load balancer, when it comes to layer 7, routes are created, and your configurations are basically propagated as it is within those routes. We perform a lot of transformations, but those transformations come afterwards. In general, your ingress would just be transported as it is. And again, don't be scared by these UIDs. I think when it comes to multi-tenancy, naming patterns are much harder to define because there could be duplicates in multiple ways. So to avoid all of those duplicates, to avoid all of these issues, we persist all of the actual information in form of labels, but the name is more or less a UID. And you can see the ingress that I created. As it is, it has been forwarded to the management cluster. And if we now go back to the browser, just a second. DNS propagation can take some time. That's already propagated. Maybe this one, or we can quickly go through this one as well. So some of my Chrome is acting up, and I think it's I think there's something wrong with the DNS propagation. But yeah, maybe I can check it while we continue with the Q&A, because I think Q&A is much more important at this point in time. So I can stop sharing my screen and maybe go through the Q&A or any questions or chat that is there. So Mar, if I see this correctly, there are no questions, right?
Yeah, so far we don't have, but someone raised their hand, so I can allow you to talk, Kristaps. Now, I think you should be able to unmute yourself and talk.
Hear me?
Yeah.
Yep, we can hear you.
I have a question regarding the services. So once you create a service, is the load balancer resource always created? Or can you specify for some services that KubeLB doesn't create one?
So in general, when it comes to layer 4, if you want to use node port with KubeLB, it's also possible. So for example, you can use node port service. But when it comes to layer 7, let's say the one, by the way, the gateway started working. I think DNS propagation took some time. But in general, when it comes to layer 7, we only use node ports. So we don't create load balancer services. We only use node port services.
Yeah, but what I mean, I saw you create a service and then the load balancer was automatically propagated.
Yes.
But in some cases in Kubernetes, you use services for internal communication between some other pods, which doesn't require access from outside. So so how can you apply then those services without creating?
Those services should work perfectly fine, because in those services, since you don't need external communication, or let's say a different ingress or entry endpoint, those services would exist just within your cluster, right?
Oh, okay.
So those services are not delegated to KubeLB.
Okay.
It should only be used, let's say, for just if you're particular with layer 4, for services of type load balancer. So when you actually require some sort of external, or it could be internal as well, load balancing. Otherwise, it doesn't touch any other service.
Oh, okay. I missed it. Can I ask another question then?
Yeah, go ahead.
Does it make sense to run the KubeLB on KKP? Or
yes.
Does it make sense?
Yes, absolutely. Okay. You can, and due to lack of time, I couldn't show it off. But in general, you can run KubeLB again. You can run KubeLB cluster, management cluster, anywhere that you want to. And within KubeLB, Mar, do you know if my Chrome tab is still visible? So can you see KKP, because my Zoom just got minimized?
Yep, we see it.
Okay, perfect. So within KubeLB, you only need to configure your management cluster somewhere, and then afterwards, everything, so for your tenant, is already automated. So you already see this checkbox for KubeLB.
Oh, yeah.
All you have to do is check this, maybe configure if you want to use Gateway API or load balancer class, and then the tenant deployment, tenant registration, everything is completely automated. When you get this cluster, KubeLB will already be installed.
Okay, perfect. Yeah. Thank you very much.
No worries. Are there any other questions?
Yeah. You can use either the Q&A section or the chat in case you have any questions. Or as K-Steps did, you can also raise your hand and I can allow you to speak as you prefer.
So I think we already have a question.
Yep.
When the first request is made for a resource, it manages the data flow. Does all subsequent data go through that same path? I think if you question if I get it correctly, and if it's about the entry point for your traffic flow, then in this case, whatever is delegated to KubeLB, so all your load balancing requests that are forwarded to KubeLB, they're also provisioned, or let's say presented through KubeLB. So your data plane, or let's say your entry point, would be KubeLB. That is what would basically show you all your, that will basically, I can't find the right word, but basically all your data will be presented from the KubeLB cluster. So for example, if you have a private cluster, private tenant, let's say somewhere in your clusters in the cloud, so accessible publicly, you can expose your private, if you want to, you can expose your private resources or applications using the managed KubeLB in cloud, because your KubeLB in itself is public, so your data plane can be made public. I hope that answers your question.
If there any other question, please feel free to type it in or let us know.
And in general, I can what I can also do is share some links in the chat that could be helpful. So for example, if you don't have any questions right now, but maybe some feedback or something comes up afterwards, you can either use our GitHub repository, which is completely open source, so any discussions or any issues or feedback can also be presented there, or you can go through our documentation or contact our product team. They can also guide you.
Yeah, thanks, Belit. We can also share these links in our email with the recording, so you have everything together. That's great. Okay, then let's see if anyone has any other question. You can, of course, type it in. And if not, we can wait 2 minutes. But thanks a lot, everyone, to join us today. Thanks, Belit, for all the explanation and the demo. And yeah, we really appreciate you attending the webinar today. I think there is no other question. So I think we can finish it up here. Belit, do you have anything else to add?
Not much. I think I just skipped one slide. So if people are present here, I think that could be really useful. Let me quickly share that, I think, because we already have 5 minutes, right?
Yeah.
So let me quickly do that. Just give me 1 minute. So you should be able to see my screen now, and probably, so this is where we were. We were talking about the demo. I think we already completed it. And then I think the one important aspect, I think it would be also important for everyone that's attending this call, is how the future looks like for KubeLB. So what are the future prospects? And instead of just naming a few features, I think we wanted to focus more on the domains or areas that we want to target KubeLB. And a few top domains, of course, AI being one of them. I think it's it's inherently a very good fit for KubeLB because things like AI gateway and even your MCP server, they can coexist with your data plane. So your API gateways, your AI LLM gateways, they should exist right next to your data plane or where all your traffic is being managed. So that instead of having something different for API gateways, something different for your ingresses, a common solution, or let's say a common set of security principles can be adopted throughout for all your products, so even for AI gateways. And then we also want to focus on multi-cluster load balancing. A feature that we're looking into is basically global load balancing. So within, let's say, if you have the same instance or same application hosted in multiple clusters, KubeLB will eventually be able to load balance automatically for n number of clusters or n number of instances. And I think I already shed some light on it before when I said that you can also directly create load balancer resources instead of just relying on tenants. But we are also working on a CLI for KubeLB. So eventually it will not only be a Kubernetes-only tool, you can use it anywhere for your VMs, for your bare metal machines. Anything can eventually be load balanced using KubeLB. And the links I've already shared in the chat, but just for brevity's sake, I would share it again. And then from my side, Mar, that's it. Thank you so much, everyone, for attending the webinar.
Yeah, thanks a lot, Walid, and thanks everyone for attending. Then, yeah, now, if there's no questions, then we can close up for today. Thanks a lot. We will send you everything, the recording, the links again. Also, we can share the slides as well, right, Walid?
Yes.
And yeah, we will share everything. So I wish everyone a good day, good rest of the day, and see you soon.
Bye, everyone.
Bye.